Hello, I'm Jake Weber, and I work in Hawkins Lab, where we investigate the chemistry of clouds and how it affects climate change. There are three main ways to investigate this chemistry. First, you could do a field experiment by taking ambient measurements, or you could run a control experiment in a cloud chamber, or lastly, you could use a computer simulation to model either the atmospheric chemical mechanisms or the mechanisms that you're specifically investigating in that cloud chamber. And this last chamber modeling approach is my focus in the Hawkins Lab. The main model we use is called PyCam, which uses the computer language Python to solve these really nasty differential equations that previous researchers have built to model the atmospheric processes. Some of the things the model can accommodate are things like particle collisions, particles sticking together, or even particles sticking to walls, and there are a few other similar interactions, but those are some examples. These models are really important because it can essentially become a really fast and cheap way to run some extra experiments that you didn't specifically run. For example, we could model how adding ozone to limonene should hypothetically affect particle growth over time. And particle growth over time is something that's important to model because the particles growing could affect their absorptivity or just their overall effect on the climate. And these sorts of interactions that we're modeling are really useful to know and useful to model because the models allow the scientists to kind of use this information to kind of also double check, but then also really look at how these particles growing should change their properties and then therefore change their effect on the chemistry and therefore by extension also on how they're impacting the climate.